Did you know most microbes that invade the body can be destroyed within minutes or hours? In the last video, we covered a quick overview of innate immunity. In today's video, we will dive deeper into the initial physical and chemical barriers that a body has to avoid infection. When a pathogen attacks the body, it first encounters anatomic barriers whose goals are to contain the pathogen and prevent infection. If they are unsuccessful, infection is initiated and the innate immunity process continues until the pathogen is eliminated. Today we will focus on these anatomic barriers. The first barrier pathogens often encounter is the epithelia, or a physical barrier of epithelial cells which are formed together by tight junctions, sealing against the external environment. The epithelia are present throughout the body, such as lining the blood vessels, glandular tissue, the stomach and intestines, the epidermis, and the respiratory tract. Due to their wide range of usage throughout the body, epithelia have specialized properties that vary depending on their location in the body and their functional needs. Major classifications of epithelia are described by their shape and cellular arrangement. If we look at shape, we can see an epithelial cell's shape can vary between squamous, or flat sheet-like cells, cuboidal, which are cube-like cells, or columnar, or column-like cells. Paired with cellular shape, cellular arrangement is an important distinguishing trait. A simple arrangement consists of a singular layer of cells, while a stratified arrangement consists of more than one layer. And a pseudostratified arrangement consists of one layer of different size cells, giving the illusion of multiple layers. These classifications of epithelium give us insight into their functions. For example, simple squamous epithelium line the blood vessels and regulate passage of substances into tissues, while a stratified squamous epithelium is protective and prevents water loss, such as the outer layer of your skin. Epithelial cells can also have distinct traits used to help perform different functions. Surface structures are often found on epithelial cells to aid in substance capture. Cilia are tiny hair-like structures that are motile, which means they move. These structures beat against the epithelia to help move mucus and other substances over the epithelial surface. Microvilli are finger-like structures which are non-motile. They increase the epithelial surface area and trap substances to improve substance absorbance. Stereocilia are non-motile like microvilli and hair-like cilia, and are generally important for epithelial tissue in your inner ear for hearing and balance. Other specialized characteristics of the epithelia are specialized cells. Internal epithelia can have goblet cells, which produce the mucus that coats the epithelial surface. The gastrointestinal tract can have penneth cells, which are specialized cells that line the bottom of deep intestinal ridges called crypts. These cells produce antimicrobial proteins to fight off pathogens. Altogether, this allows us to have a variety of epithelia with varying properties to serve the needs of all the areas of your body. For example, if we look at the epithelia of the respiratory tract, we find a pseudostratified columnar endothelia that contains goblet cells for mucus production and cilia to trap substances and expel them from the airways. Alternatively, if we look at the epithelia of the digestive tract, we can see a simple columnar endothelium, which have goblet cells to produce mucus, microvilli to aid in nutrient absorption, and penneth cells to produce antimicrobial proteins to fight bacteria and maintain your microbiome. Both of these examples gives us knowledge on some important factors of internal epithelia, such as the production of antimicrobial proteins, mucus secretion and coating, and methods to move substances across the surface. The production of antimicrobial proteins and mucus allows the epithelia to not only be a physical barrier, but a chemical one as well. Classes of antimicrobial proteins, such as enzymes like lysozyme and secretory phospholipase A, antimicrobial peptides, and lectins, are produced and secreted into fluids like mucus, saliva, and tears to kill bacteria before it enters our system. We will discuss these more in the next video, along with the complement system. In today's video, we looked more closely at the properties of the epithelial, including shape, cellular arrangement, surface modifications, and specialized cells. If you enjoyed today's video, leave us a like, and leave any questions you have in the comments. If you enjoy our other content or want to see more of this type of content, help our channel grow by subscribing.